Section 5. When we graph rational functions, we are going to run into asymptotes. Now, in previous math classes, we've talked about asymptotes before. An asymptote is a line that what? My graph keeps getting closer and closer and closer and closer and closer, but it never arrives at it. Now, back in Algebra 2, when we did some graphing, we never crossed our asymptotes. It actually is possible to cross an asymptote. The definition of an asymptote really means my function approaches that value. So this asymptote, maybe it's the line y equals 1. My function is approaching 1 as my x is getting to positive infinity, or as my x goes to negative infinity. I can be going to the right or to the left. Really just means I'm approaching that value. Here they've given us an example where as we go to the left, we can see, hey, we're approaching the line y equals 1. As we go to the right, our graph is approaching the line y equals 1. Let me bring back up this graph over here. It happens to be this top rational function, that x squared plus 1 over x squared plus x minus 2. Now, if I put in the horizontal asymptote on this one, notice over here going to the left, we can see I'm getting closer, 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 closer. We never actually hit that. We just keep getting closer and closer and closer. But as I go to the right, as my x values go to the right, you notice how it actually crosses that. And then it starts coming back up, getting closer and closer and closer from the bottom. So we actually can cross and touch horizontal asymptotes. But as we go to infinity or negative infinity, we're going to reapproach it, get closer to it again, and never touch it that time. So how do I possibly see different asymptotes? Well, we can see different asymptotes approaching from the bottom. We can approach it from the top. Or, similar to the one I just saw, we might cross it and then start coming back up. And we can do it from the bottom. We can go across it going up and then start coming back down. So that's really the definition of a horizontal asymptote. As my x's are approaching infinity or negative infinity, it's the value that we get closer to. Vertical asymptotes are a little bit different. Vertical asymptotes, they're where the graph just heads to infinity or negative infinity when I start approaching some x value. Let's look at a picture. I think the picture will help. There was my horizontal, y equals 1 on this one. Well, this has two vertical. X equals 1 is one of the vertical asymptotes. If I start on the far right and move back to the left, I start shooting up to infinity on the right side of that. Or if I start down here where it kind of looks like a parabola, if I start moving towards the right, I shoot down to infinity. As my x's are approaching that 1, I either go up or I go down. X equals negative 2 is another vertical asymptote on this. From the left side, it shoots up. From the right side, moving back to the left, it shoots down. Those are vertical asymptotes. I either head to negative or positive infinity at vertical asymptotes. And rational functions have these different asymptotes. So we're going to first learn, how do I find where the vertical asymptotes are located? Well, if I have a rational function, in other words, something is divided by something else, one polynomial divided by the other, the vertical asymptotes are where the 0 of the denominator is. What makes the denominator equal 0? One little caveat that we're going to pick up at the end. As long as there are no common factors, in other words, as long as I couldn't factor and reduce this is true. We'll later get to ones that I can factor and reduce. But as long as I can't factor and reduce, then I just look for the zeros of the denominator. And that is going to be the vertical line where I have an asymptote. So we are going to find the vertical asymptotes of these functions. So I look at the denominator, and I say, what makes x squared plus 1 equal 0? Subtract 1, x squared equals negative 1. plus or minus square root. What is the square root of negative 1? I. Plus or minus I. Uh-oh. That's an imaginary number. The very first example they gave you about finding vertical asymptotes is really no vertical asymptote. I didn't get a real number where that denominator equals 0. Here happens to be the graph of it. Where did it go? There we go. There's actually no vertical asymptote on this one. Kind of a bad way to start. So let's start with go to the next one. This is a better way. I want to find the vertical asymptotes. Where does this equal 0? Well, I need to factor that so I can figure out where it equals 0. X times x, we could do negative 3, positive 2. Multiply negative 6, add to be negative 1. So what values of x make it equal 0? 3 and negative 2. So the vertical line x equals 3 and the vertical line x equals negative 2 should be the vertical asymptotes. There's the graph of it. And sure enough, x equals negative 2, x equals 3. There are the vertical asymptotes. So far, we've learned how to do one thing on graphing these. Find the vertical asymptotes. The 0 of the denominator. Now, what happens at vertical asymptotes? Well, we already know vertical asymptotes are where it goes to infinity or it goes to negative infinity. If the degree of that factor, x minus a to the n, if the degree of that factor is odd, first power, they go in opposite directions on either side of that asymptote. We don't know which way yet, but they just go in opposite directions if it is an odd one. Let me back up here. These were odd powers. These were to the first powers. So on either side of these lines, my graph should be going in opposite directions. And sure enough, it is. It's going in opposite directions. That one's down, this one's up. It's going in opposite directions on either side of it. If the degree is even, then it's going to be going the same direction, both to positive infinity or both to negative infinity. Haven't seen one of those yet. So that's the vertical asymptote there. So how do I find horizontal asymptote? There are 3 rules we are going to learn. And the rules all come from comparing the degree of the numerator polynomial, this is degree n, and the denominator polynomial, degree m. So in other words, I might have 2x squared plus 3x minus 1 over 7x cubed plus 4x squared minus 3x plus 8. This is a second degree over a third degree. All of these steps come from comparing the degrees. If the numerator is less than the denominator in degree, that was my example. I have a second degree over a third degree. 2 is less than a 3. Your horizontal asymptote is automatically y equals 0. That's where it will occur. If the degrees equal each other, let's say I had a second degree over a second degree, or a third degree over a third degree. If the degrees equal each other, I just divide the lead coefficients. 2/7. It would be y equals 2/7 in my example if the degrees were the same. A over b, those are just the lead coefficients. That's where the horizontal is. Now the two numbers have only 3 possibilities. The top one is less than the bottom, the top one equals the bottom, or the top one is greater than the bottom. And that's the third rule. If the numerator degree is greater than the denominator degree, then there is not a horizontal asymptote. And we will learn later what kind of asymptote it is. Today, but later. So let's apply these rules. How do I find horizontal asymptotes? Well, I compare the degrees. That's a first degree over a second degree. So the numerator is less degree than the denominator, so that means what? y equals 0. There's my horizontal asymptote. This one has a second degree over a second degree. The degrees are the same. So my horizontal asymptote is what? Y equals 4/3. I have a third degree over a first degree. So what? No horizontal asymptote. There is an asymptote, but that's later. So how do I graph these things now? The key to graphing them is finding the asymptotes. I find the vertical asymptotes by setting the denominator equal to 0. Then I find the horizontal asymptotes by applying these rules. So the very first thing I do in trying to graph these things is figure out where the asymptotes are. Then we are going to figure out where intercepts are. We've done this before. Intercepts. The zeros of the numerator, where the numerator equals 0 is where the function equals 0, and those are the x-intercepts. We'll practice this here in just a minute. The y-intercept is where x is 0. Hadn't gone anywhere in the x. That's where it crosses the y-axis. So for the y-intercept, we do the x is 0. Where is it? F of 0, right there. You just substitute 0 into the equation. You get the y-intercept. We're not going to do much with symmetry. But we are then going to get some additional points so we can fill in the blank spots. And when we get additional points, I'm going to pick points that are near the asymptote because that will help tell me whether I'm going up or down near the asymptotes. And then we sketch the graph. So let's try, we're going to do those 4 techniques, and then the last one, sketch the graph. So number 1 is the vertical asymptote. Wherever it says vertical asymptote. So number 1, if I want the vertical asymptote, I take my denominator and set it equal to 0. X squared plus 3 equals 0. Oh, guess what? Tell me about the vertical asymptote. There isn't one. That's an imaginary number. There isn't one. So now let's look for the horizontal asymptote. Well, for the horizontal asymptote, we compare the degrees. These are both second degrees. Y equals what? 2. 2 divided by 1, the lead coefficients. 2 divided by 1 is 2. Y equals 2. All right, I can put that in. Y equals 2. Now I'm just going to put a dashed line on the outside of my graph. Because remember, it's only as I approach negative infinity or positive infinity. So step 1, I have figured out where my asymptotes are. I'm going to work on step 2 now, figuring out where my intercepts are. And if I want my x-intercept, that means where does the numerator equal 0? Because 0 divided by anything is 0. Where the function equals 0 is on the x-axis, the x-intercepts. So where is 2x squared minus 18 equal to 0? 2x squared equals 18. X squared equals 9. X equals plus or minus the square root of 9, which is plus or minus 3. I have 2 x-intercepts. A positive 3, my graph crosses, and a negative 3, my graph crosses. Going to get the y-intercept. We find the y-intercept by making the x 0. So what I'm doing is f of 0. We're putting a 0 into this equation. Well, if I put a 0 where the x is, that's 0. I get a negative 18 on top. If I put a 0 where the x is, 0 plus 3 is 3. What's negative 18 divided by 3? Negative 6. You're going to have to gently wake up your neighbor. Y-intercept is negative 6. So on my y-axis, I'm going to go to negative 6. Now that's another point on my graph. So we have accomplished 2. Now, we need additional points, and I want those additional points near my asymptotes if I have any. Well, I don't have any vertical asymptotes. So let's just back up to the left and to the right to see where does it go when it approaches these horizontal asymptotes. So I'm going to label it 4. I'm going to make a table of values, and I'm just going to choose some x's that maybe will help me out, like a -10 and a +10. I want to see what happens when I get near the ends. So I'm going to do f of -10. I'm substituting a -10. See if we can do this mentally. What's -10 squared? 100. What's 2 times 100? What's 200 minus 18? 182. Good answer. I'm going to put a -10 down there. -10 squared is 100. 100 plus 3 is 103. Divide that for me on your calculator so I know approximately what it is. So about 1.8. Now I'm going to put in a +10. It's the same thing. If I put a +10, I'm squaring it. It's going to be exactly the same thing. I get approximately a 1.8. A 1.8. So at -10, I'm at 1.8. At +10, I'm at 1.8. Let's connect the dots. I know I am approaching this asymptote. I've got to go through that dot. I've got to come down to this dot, and polynomials are always smooth. Hey, I'm pretty proud of that picture. What is it really supposed to look like? Here's what it's really supposed to look like. So let's try another one, since we were so good at that one. So step number 1 is going to be the asymptotes. You tell me, how do I find the vertical asymptotes? It's okay to refer to your book if you need to. Zeros of the denominator. Now, what I usually do before I do anything else is I factor this thing. Well, x squared plus 1, I can't do any factoring of that, but down here I can factor. Let's see, +2 minus 1. Does that make it work? That makes it work. Well, zeros of the denominator, x plus 2, x minus 1 equals 0. So you tell me where the vertical asymptotes are. -2 and +1. -2 and +1. So at x equals -2, there's a vertical asymptote. At x equals +1, there's a vertical asymptote. What do we do to find the horizontal asymptotes? We look at the degree, second degree over second degree. So what does that tell me to do with the leading coefficients? Divide them. What's 1 divided by 1? Y equals 1. So y equals 1. Now I'm just going to, like last time, just kind of do it off to the edges, because in the middle, I'm not sure what happens. We can actually cross, but as we get to the ends, we're going to approach y equals 1. The next thing, we're going to look at intercepts. If I want the x-intercept, what do I do to get the x-intercept? Numerator equals 0. Where does the numerator equal 0? X plus 1 equals 0. Can you tell me the answer to this? I skipped a few things there. Square root of -1. Guess what? We don't have any x-intercepts. We got an imaginary number. We never touch the x-axis on this one. Okay? Y-intercepts. What do we do to find the y-intercept? Y-intercept is where x is what value? 0. I take f of 0. I substitute a 0 into it. Well, 0, 0, 0, all those things go to 0. What do I have left? Yeah, 1 divided by -2, -1/2. There is a point at -1/2. Right there is our y-intercept. That's the only point we know so far. It was number 4 on their list. we want to now do some points. And I want to choose my points near my asymptotes to help me know what to do. I'm going to again choose a -10 and a +10 so I know what my ends are doing. And then I'm going to choose things by these asymptotes, like a -3, -1, -3, -1. I already have 0, so I'm going to choose a +2. So I'm just choosing values near my asymptotes. Now we're going to substitute this in. -10 squared is 100 plus 1. I have 101. That's 100 minus 10 is 90, minus 2 is 88. What does that give us approximately? 101 divided by 88. Say that again? 1.1. If I put a 10, now this will be a little different. 10 squared is 100 plus 1, that's still 101. 10 squared is 100 plus 10, 110 minus 2. 110 minus 2 is 108. Divide that one. How much? 0.9. About 0.9. -3. -3 squared, that's 9 plus 1 is 10. Let's see, -3 squared. So 9 minus 3 is 6, minus 2 is 4, so 5 halves, 2.5. Is that right? So I should have, well, let's just keep doing this, and I'll put my points on. -1. 1 plus 1 is 2. 1 minus 1 is 0 minus 2, -2. That's -1. 2n, 2 squared, 4 plus 1 is 5. 4 plus 2 is 6, minus 2 is 4. 5 fours, so that's what? 1.2? 1.25, 1.3, sorry, approximately. -10, 1.1. So I know I'm just above it. 10, I'm at 0.9. I'm just below it. -3, 2.5. -3, 2.5. -1, -1, -1, -1. 2, 1.3, 2, 1.3. Now let's use some ideas. I appear to be above this asymptote, and when I come over here, I'm heading up. I bet I'm heading to positive infinity there. And that -2 was an odd power, so I know on the other side it's going to be heading down. It's going to go through those points. Let's come over here and see what happens. I'm below this asymptote. But as I come back here, I somehow end up above it. I bet I dip down and then I head above it like that. Now this +1 was an odd power again. That +1 was an odd power. So I bet it does opposite things on the two sides. I bet it goes down there. Drum roll. There we go. My dip wasn't exactly right. I have a bigger bump than really happens down there, I guess. So it wasn't quite so dramatic as I made it down there. But we have a sketch of that rational function. All right. So we are all prepared to graph rational functions that have horizontal asymptotes. Now we need to prepare for what do I do when that degree on top is 1 greater, the degree on top is 1 greater than the degree on bottom. Back up here we said if the degree on top is bigger, there's not a horizontal. Well, there's not a horizontal. There's what we call a slant asymptote. Let me give you a picture. A slant asymptote is just a slant line. This equation right here has a slant asymptote. The equation of that slant asymptote is right here. Y equals 2x plus 3. if I zoomed out too much, notice we're approaching that line on both ends. We're approaching that slant line. So how do I get that slant asymptote? As my x's approach to 0, I approach some slanted line. Notice they put it mx plus b. There's some line that I approach. Well, how we do it is we divide, and the quotient is the equation of the slant asymptote. So this has a slant asymptote because I have a third degree over a second degree. The degree on top is exactly one bigger. If you would have taken pre-calculus, we would have seen, what do you do if it's more than just one bigger? See, you're missing out on some of the fun, but you'll still have fun with this. I need to divide. I need to take this numerator divided by the denominator. And we do long division. 2x cubed plus 5x squared. And we remember I'm missing an x, so I'm going to fill that in with 0x, and then my plus 1. We need to divide that by x squared plus x plus 3. So do you remember how to divide? X times what is 2x cubed? 2x. So I'm going to put it over its like term, and then we're going to take the 2x and multiply everything out here. 2x cubed plus 2x squared plus 6x. Then we're going to change our signs and just add these things together. So those cancel. 5 minus 2 is 3x squared. 0 minus 6 is negative 6x. Bring down the plus 1, and we repeat. X squared times 1 is 3x squared. 3 plus 3. Multiplied by 3. 3x squared plus 3x plus 9. Change our signs. Add it together. Those cancel. Negative 6 minus 3, negative 9x. 1 minus 9, negative 8. Can I take x squared and multiply it by something and get negative 9x? No, that's the remainder. We don't care about the remainder. We just care about that. That is the slant asymptote. Y equals 2x plus 3. This one happens to be the one that I showed you. Y equals 2x plus 3. There it is. That line. Y-intercept is 3. Y-intercept is 3. Slope is 2. It's a slant asymptote. They didn't ask us to graph this one. They just said find that slant asymptote. Now, we need to look at what happens when there's actually a common factor on the top and bottom, and we could cancel and reduce it. Well, let's first get this factored so we can see what the common factor is. X times x. What numbers do I need to get that? Negative 4 plus 1. Down here. X times x. Negative 4, negative 2. I've got a common factor right here, don't I? If I have a common factor, it means those things would reduce out, leaving me x plus 1 over x minus 2. But that's not the original. The original included this. But I cannot have x equaling a 4 because it would make this undefined. I can't divide by 0. 4 minus 4 is 0. So on this new one, I just need to remember x cannot really be a 4 on that new one. And now I'm going to just look at the new one over here and go through my procedure. I need to find my asymptotes. And I'm going to first look for my vertical asymptote by what makes the denominator 0. X minus 2 equals 0, where x equals 2. Okay? X equals 2, there's a vertical asymptote. My horizontal asymptote, I'm going to compare the degrees. They're both first degree. What do? Lead coefficients. 1 divided by 1 is 1. Y equals 1. Y equals 1. That's been a popular horizontal asymptote. y equals 1, y equals 1. So I'm working with that new reduced one, but I'm going to have to keep in mind that x cannot be 4 on that new one. Next thing I am going to do is I'm going to look for x-intercepts and then y-intercepts. I know x-intercepts are where the numerator equals 0, x plus 1 equals 0, that's where x is negative 1. X-intercept at negative 1. Whoops, that's not negative 1. X-intercept at negative 1. Y-intercept, what do we do? There's a lot of me talking, I have to try to stay awake. After I get the y-intercept? X of 0, substitute a 0 into it. 0, so that would be what? 1 divided by negative 2? Negative 1/2? We've seen that before. Here's my y-intercept. I now am going to pick some points, and I want to pick some points near my asymptotes to kind of help me out like before. I like that negative 10 and positive 10. I'm going to do a 1 and a 3. Those are on either side of my vertical asymptote there. A 1 and a 3. And then I'm also going to choose a 4. Now in the original one, I really can't use a 4. But in this new one, I can use a 4. And we'll see what meaning that has. So let's put a negative 10. I just do the new one. Negative 10 plus 1, so that's negative 9 over negative 12. So positive 9 twelfths. What is it? Negative 10, positive 9 twelfths. So I'm right about there. 10 plus 1, that's 11. 10 minus 2 is 8. That's just a little over 1. And that's really all I care is approximately where is that? Just a little over 1. 1, 2 over negative 1, negative 2. 1, negative 2. 3 plus 1 is 4. 3 minus 2 is 1. 4 over 1, 4. 3 comma 4. 3 comma 4. And now, what if I put a 4 in there? 4 plus 1 is 5. 5. 4 minus 2 is 2, so that's 2.5, 2.5, 2.5, 4 comma 2.5, 4 comma 1, 2.5. That is a hole at 4 comma 2 and 1/2 in my graph. I'm going to use my asymptotes, go through those points. I stayed underneath, so it's doing something like that. This one is above, it goes right through that hole, and then it's heading up just like this. There's our graph of this new one. If there is a common factor, it means there's a hole in your graph. There's one spot missing. If you graphed it on a calculator or software, you wouldn't see that because it's just one little pixel, and you won't see that. So how do I use rational functions? Jordan averages 30 miles an hour during 12 miles of city driving. For the remainder of the trip, she drives on a highway at a constant rate of 60 miles an hour. So first she starts at 30, and then she goes at 60. So her average speed for the entire trip is not add 30 and 60 and divide by 2, because she's going different distances at those speeds. So here's the equation. They say this is going to give the average speed. X is the number of miles she happens to drive on the highway. How far will she need to drive on the highway to bring her average speed for the entire trip up to 50 miles an hour? They are asking, where does this equation equal 50? This is the equation for average speed. So we are just working with rational functions, reminding us how we solve rational functions. Here what I'd do. I'd get rid of the fraction. Instead of dividing by this, I'm just going to multiply by it over here. 2/5 plus 1/60 x. That'll get it all on the same line at least. So let's see what I have now. 12 plus x equals, distribute, 5 goes into 50, 10. 10 times 2, that's 20. Well, here those would reduce. I'd get 5 over 6, 5, 6x. Solving for x. I'm going to subtract 5, 6 from 1. That would be 1, 6x. I'm going to subtract 12 from 20. 8. If I get rid of the 1/6, multiply by 6. If she does 48 miles on the highway, she will have brought her average speed up to 50. Determine the horizontal asymptote of the graph and explain the meaning of the horizontal asymptote in the context of this application up here. The horizontal asymptotes, so part B, they had S of x, 12 plus x divided by 2/5 plus 1/60th x. I need to try to simplify this. And instead of dividing by fractions, I can multiply by the reciprocal of this thing. 5/2 plus 60x. Instead of dividing, I'm going to multiply by my reciprocal. Is that what I want to do? I don't think that's what I want to do. So we're going to erase that from everybody's memory. I don't know what I want to do. We're going to go look at the book to remind myself what I want to do. There's been a lot today, hasn't there? Oh, I know what I wanted to do. They're asking for the horizontal asymptote, aren't they? What do I do to find the horizontal asymptote? I compare the degrees. This is a first degree over a first degree. These are really the lead coefficients here, 1. So if they're the same, what do I do with the lead coefficients? I divide. 1 divided by 1/60th is really 1 times 60 over 1. So 60, y equals 60. Y equals 60 is the horizontal asymptote. Here's a graph. Here's the line, y equals 60. This stood for the average, well, find the remaining trip she drives on a highway, her average speed. There you go. This stands for her average speed, where x is the number of miles she has driven. The more miles she drives, the closer it approaches to 60 miles an hour average. Does she ever reach 60 mile an hour average? No. What does that stand for? The maximum average speed she approaches. She can't ever actually average 60, but she can get as close to 60 as she wants. Just keep driving longer and longer and longer. Solve an application. Write the total surface area of the can as a function of the radius r. Total surface areas. If I have a cylinder can, here's the surface area formula. The top and bottom are circles, pi r squared, 2 pi r squared. The sides of the can, 2 pi rh. So that's the surface area formula. So if I want to write the surface area as a function of only the radius, surface area as a function of the radius, well, my 2 pi r squared is fine, but over here, 2 pi r h, I can't have an h in my formula. Well, they told us the volume was 21.6, so I can come back here. This is the volume formula, pi r squared h. So 21.6 is my volume. If that equals pi r squared h, I could solve for what the height was, divide by pi r squared, and I could take that value of h And I could substitute it over here. 21.6 divided by pi r squared. And if I simplify this, I don't have any h's. Pi's cancel, one of the r's cancel. The surface area in terms of the radius is 2 pi r squared plus 2 times 21.6 is 43.2 divided by r on the bottom. There's the equation that tells me the surface area of the can if I only knew the radius. Use a graphing utility, we're going to go to Desmos here, to estimate the value of r to the nearest tenth of an inch. That produces the minimum surface area. This is a rational function. And if I graph it, we are supposed to have some sort of minimum. I graphed it. And we ran across a minimum on it. The minimum occurred when the radius was 1.509 inches. And that happens to be the surface area. When the radius is 1.51 inches approximately. I am now finally done talking. There is a lot there, I know.